Hey everybody, it's Miss Moran and I'm here to talk to you this week about division of larger numbers. We're going to try to relate everything that we're doing in this unit to stuff we've already learned how to do. So we're basically going to treat this entire division chapter as nothing more than multiplication. And we're going to show the students how using inverse operations you can solve any division problem just by multiplying. So we're going to use that strategy throughout, and also I'll introduce you to the partial quotient strategy, which will give us an exact answer and is much related to long division. All right, we're going to start off first with using an estimate. So an estimate is going to help us with our mental math and help us to develop our number sense a little bit with what it means to really divide. And so we're going to turn every division problem, this entire unit, into a multiplication question. So when I'm doing 152 divided by 4, my question really becomes 4 times some number equals 152. Well, I don't know 4 times some number equals 152, but I can try to get close to it using estimation. And I'm going to use, this is my language we're going to be using in this chapter, using as big of numbers as we possibly can, but also as easy of numbers as we can, which would be things like 10s, 20s, 30s, and 40s, or 100s, 200s, and 300s. Anything that ends in zeros, basically. So coming back over here, just 4 times some number, or 4 times some easy large number get me close to 152. Well, 4 times 10 would only be 40, that's too small. 4 times 20 would be 80. 4 times 30 is going to be kind of close. 4 times 3 is 12, so 120. And then the next 10 above that is going to be 4 times 40, which is 160. 152 falls between 120 and 160. So the answer to my division problem is going to be in a range between 30 and 40, with my answer being closer to 40 because 152 is closer to 60. Very important that students don't think this is the answer. This is the answer you get when you multiply, but we're looking at division, so we're looking at this smaller number as we work backwards with multiplication. So my answer to 152 divided by 4 is going to be somewhat close to 40. I'll give you one more example of those. This is 252 divided by 6. We're going to turn that into the multiplication of 6 times some number equals something close to 252. Okay, 6 times. Students will start to figure out this is kind of like 250. In order to make that easier, it's kind of like doing our basic fact, 25. That makes it a lot simpler. We already worked with division with remainders last week, so students should be able to pretty quickly pick up that 6 times 4 is 24, so 6 times 40 is going to be 240. It's a little bit below that. My next 10 above that is going to be 6 times 50, which is 300. So 252 lies between these two values. 252 is closer to 240, so I'm going to say that my estimate is between 40 and 50 this time, with 40 being a closer and a better estimate, so somewhere around 40. So we're going to use that concept to actually start getting us in the right direction for dividing numbers. So we're going to look at 135 divided by 3. We're going to turn this into 3 times some number equals 135. Okay, so I'm going to go as big as I can, but as easy as I can without going over 10s, 20s, 30s, and 40s. Looking at this, we can go about 3 times 40 is going to be 120. So we're going to say, well, that's part of my number. We're not doing an estimate now, we're trying to get an exact answer. So far, if I did 3 times 40, it would be 120. But I still have how much left of my number that needs to be divided. 135 minus 120 is 15 left. So 3 times what number? It's going to give me the last part of the 15. 3 times 5 is 15. So the answer to my division problem is these two parts of the problem added together. So these two together make 135. This is the answer I'm looking for. So this is going to be 45 is going to be my exact answer. And then also we have another example here, 145 divided by 5. 5 times some number equals 145. So thinking of my numbers as big as I can, but as easy as I can. 5 times something is going to give me close to 145. 5 times 10 is only going to be 50. 5 times 20 is going to be 100. 5 times 30 is 150. That's too big, and even though it's close to it, I can't go bigger. So we'll go with 5 times 20 is 100. How much left of my number do I have? 45 left to divide. So 5 times what number is 45? 5 times 9 is 45. So my answer is these two together, 29. Now I'm going to show you a strategy that we're going to use that is sort of a visual representation of this, that relates to the partial products that we did in our multiplication chapter. It's not a strategy we're going to spend a lot of time on, but it does help students to understand where this sort of break apart model comes from. So in this, remember, we were breaking apart large numbers into simpler numbers to multiply. So we're still doing 5, but this time, instead of knowing this factor over here, we're looking for it. And what we already know is the total value here. So this is where we're working backwards. So 5 times some number is 145. This whole thing is 145. Well, we're going to multiply up as much of that as we can in chunks. So like I said, 5 times 10 is only 50. 5 times 20 is 100. How much is left? 45 is left for over here. So 5 times what number? 5 times 9. So my answer, 29, is in these two values added together. So again, just a representation showing that we're really just taking this number, 145, and we're breaking it up into little chunks that are easier to divide, or in our case, we're going to multiply as a means to do division. Again, we won't spend a lot of time on that, but we will relate what we're doing to that, because the students already know how to do that. Okay, next comes partial quotients. Partial quotients is basically the whole number value foundational understanding of where our long division strategy comes from. We are not going to be doing long division in class at this point, just because of the amount of time it takes to introduce a whole nother strategy. And this is just as effective of a strategy for what they're going to need to do in 4th grade. Towards the end of the year, we may introduce it. Some students may already know how to do it. You may do long division at home. There's a handful of students whose parents have already shown them, and that's fine. But I'm going to show you this because it is, I think it's very neat, and it does teach kids how to use whole numbers instead of just, following the digits and putting numbers here and following a bunch of steps. So we're going to do the same thing as we've already done. Multiplying as close to the dividend as possible using big but easy numbers, and then we're going to subtract and then keep multiplying until we've finally divided the entire dividend. The only difference about this is when we're doing this, like long division, we're going to write it up and down, and we're going to show basically multiplication and subtraction until none is left. Well, instead of putting digits in a place, we're going to just keep track of our multiplication here in a few steps. So I'm going to start by asking myself, can I think of a number 4 times something that equals 268? Well, I don't know 4 times something equals 268, but I want to go as big and as easy as possible and as close to this as I can. So that would be 4 times, just like we did on the previous page, 4 times 10 would be much too small. 4 times 40 even is only 160, so I'm going to try to go as big as possible. Again, looking at those first two digits is going to help. So 4 times 60 is going to be 240. Again, just multiplying what we already learned in our last chapter. That's nothing new. Now we've divided part of the number, so we still have some left that needs to be divided. So we're going to subtract. There's 28 left over, and then we're going to divide again. And I'm going to ask myself, 4 times some number equals 28. 4 times 7 is 28, and that leaves none left over. This is my answer over here, these two parts of the problem added together. 67 added together is my final answer. Okay, so it looks kind of like long division. There's really only one difference, is that these numbers are written out here in whole value rather than just digits across the top. All right, here's one that's a little bit bigger. This is 729 divided by 3. So this time if I go 10s, 20s, 30s, we're not getting anywhere near that number. I'm going to have to go much bigger. I'm going to have to get into the hundreds here. So 3 times 100 is just 300. That's not quite big enough. 3 times 200 is 600. That's closer. 3 times 300 is 900. Too big. So I'm going to go with 200. So 3 times 200 is 600. Subtract. How much is left? Okay, still just using multiplication. None of this is division, it's all multiplication and subtraction. So how much is left to divide? Because we've only done part of it. That's why we call it partial quotients. 3 times 40 is going to be 120. That leaves 9 left over. And 3 times 3 is going to be 9. That leaves none left over. My answer would be all of this over here, which is 243 for a final answer. Now, one of the great things about this is if you're not real strong on your facts, or if these numbers get big, you don't have to do it like I did it here. You can do it in steps or in chunks. So let's say you just did 100. You want to start off there because you knew that was an easy number to multiply. Okay, well, 729 minus 300, that's 429. Well, you could take another 300 out of that by doing 3 times 100 again. That leaves you with 129. All right, you might say 3 times, and you could go straight to 40. Let's say you didn't know that though. Let's say you just did 3 times 20 because that was easy for you, 60. All right, 3 times another 20. It's going to be 60 again. And that leaves you with 9 left over. We still got to keep dividing. 3 times 3 gives me 9, and none left over. Now that's a lot of partial quotients, but even if you did it in smaller chunks, this is 240 and 3. So same answer, doing it with facts that were simpler for you. Students will learn that to get there in the fewest steps, you've got to go as big as possible in one step, but you don't have to do that. So this strategy is great, especially if, I mean, this was an easy number because it was 3, but sometimes if you're working with larger numbers, your 6, 7s, 8s, or 9s, and you're not great with division, you can just take away little bits of numbers that you do know and use facts that you can do. Now again, some of you may be looking at this going, this is silly, just teaching the long division strategy. The long division strategy has a lot of steps. Divide, multiply, subtract, bring down. You got to put things in the right place. Everything has to be lined up. You got to do everything in a certain order. It can be, you know, it's not hard, but it takes a lot of practice. And this doesn't take much practice because all it is multiplication. And I want to show you really how this is really no different from long division, the traditional long division, because I know parents want to stick to that because that's what they know. So in long division, I'm going to divide. Try to do 4 into 2, which you can't do. 4 into 26. 6 times 4 is 24. Okay, so if you look here, it's exactly the same as what we have over here. Only instead of this just as place values, this is 26 minus 24 tens. This is the actual number, 240. It's just missing 0 here. Okay, then we'd say we subtract. 6 minus 4 is 2. Then we bring down. Okay, that means absolutely nothing to students. Here we can see that what that means is that that's how much of the number you have left to divide. We're at the exact same spot. The only thing missing is a 0 there and an actual value. Okay, and then 4 goes into 28 7 times. Okay, with none left over. Okay, again, they look very similar. This is a long division strategy. You're doing the same thing. You're dividing basically by multiplying and then subtracting until you have none left of your number. So if this is something that you feel very strongly about, I want you to realize that this is really pretty much the same thing. It's just using whole number values, which is a lot simpler for kids to use instead of learning a whole nother strategy that's unrelated to something they've already done. Multiplying, subtracting, they already know how to do that. All right, I thank you so much for your time. I know this one's a little bit long, but this is a very important unit and we're going to spend quite a bit of time here. So thank you for practicing at home. And go ahead and like and subscribe.